Okay, we're going to do something called Newton's method. You're not going to get an assignment today. You will get an assignment when we return, so either tomorrow or Friday, okay? And it'll be your last worksheet. I'll give you a homework cover sheet and a study guide and whatnot. Right now, it looks like we would be testing about next week, Wednesday. It's right now about where we would be. What's that? I'm banking on a snow day tomorrow. There was. Yep. I'll get you that when you come back. Otherwise, you can grab it right here. Okay. Newton's method is super cool, and today is a nice day where I said you don't have to get right to an assignment afterwards. You can take this in and enjoy it. It's our last topic of differential calculus. After this, when we get back, we'll get to integral calculus. It'll be a lot of fun. And furthermore, I want you to know that the second hour definitely had some aha moments for like, well, that's actually pretty cool. So here's the idea. You got to put yourself in Newton's situation back in the year 1600, okay? You don't have a calculator. And so how do we accurately approximate irrational zeros or solutions? Or in other words, what is the square root of 5 accurate to 4 decimal places? Okay, we'll try this out, okay? Hunter, what's the square root of 4? Good. Okay, Carter, what's the square root of 6? Okay, you don't know. All right, Jasmine, what's the square root of 9? Okay, Callan, what's the square root of 8? 2 something. Okay, so if you notice, Hunter and Jasmine had no problem coming up with the answers, but these two did. Okay, I didn't really change the problem that much, did I? Okay, all right, thank you. What's a double square root or something? So the point is that when we come up with irrational numbers, it's very difficult to compute, isn't it? Let's see what Newton would have done in that situation. What he does is he creates a function, y equals x squared minus 5. Anybody know why he chose x squared minus 5? Where does it cross the x-axis? It crosses the x-axis at the root of 5. He said, if I can find that spot, then I know the root of 5. Well, if you set it equal to 0, okay, now, we're going to take Cal's idea here and say, Callan, what is the square root of 5? And you're going to say 2 point something, right? So the square root of 5 is between what two integers? 2 and 3. So he knows he's got 2. He knows he's got 3. Is everybody good with that? And so Newton starts with this function. He says f of x is equal to x squared minus 5. And he says, I'm going to make a guess. And it's going to be a really bad guess, but I'm going to make a guess. I'm going to guess that the square root of 5 is 3. I call that x sub 0. And when he guesses 3, when he plugs in 3, he wants to come out with 0. But when he plugs in 3, he comes out with a different number. What do you get if you plug in 3? You plug in 4, right? And he says, that's all right. I can see that I'm way off, but I'm going to deal with it. He says, I'm going to use that spot to find a better guess. And here's how he comes up with a better guess. And this is what makes it awesome. He draws a tangent line. A few. He says that tangent line crosses the x-axis right here. Is that a better guess than 3? It is. So what he says is, I want to write an equation for a line. And I want to find where it crosses the x-axis. Well, in order to write an equation for a line, I need a point on the line, and I also need the slope. Well, what's the x value for the point on that line? 3. What was the y value? 4. How do we find the slope of a tangent line? Take the derivative, and that's where we'll pick up when you get back. Go get some brain food, come back smarter. All right. Yep. Here, let's get back to it. So Newton makes an initial guess of 3. Okay. He plugs 3 into the function. 3 squared is 9, minus 5 is 4. Okay. He wants to come up with 0. Because if you take the square root of 5 and square it, you get 5. Minus 5 is 0. So he gets 4. And so what he wants to do is he wants to write an equation for this line and find the x-intercept. We found the point of the line is 3, 4. How do you find the slope of a line tangent to a curve? Very good. What's the derivative? What's f prime of x? It's 2x. And so if 2x is the derivative, then what would be the slope? 6. Why is 6 the slope? Because 2 times 3 is 6. So I write an equation for that line, y minus y1 is equal to m times x minus x1. But before we write that equation, please consider the y value of the x-intercept. What is the y value right here? 0. So therefore, we can turn y into 0, and we get negative 4 equals, the slope is 6, times x minus 3. Divide by 6, I get negative 4 over 6 is equal to x minus 3. Add the 3 over 3 minus 4 over 6 is equal to x. Or 3 minus 2/3 is 2 1/3, or 2.3 repeating. We all good with that? That's an approximate square root of 5. Now, we're going to look at it, come up with a better approximation, but I want you to look at something here. Look at what we came up with for an answer. Where did the 3 come from? That was our guess. Where did the 4 come from? That was f of 3, right? Where did the 6 come from? That was the slope at 3, right? So you take your guess minus the function at that spot over the derivative at that spot, you get the new guess. And we're going to derive a formula, and it's going to look just like that as we come up with our new guess. Now, let's look at this 2.3 repeating, okay? I take out my calculator, and if we take 3 squared, you can see you get 9. We knew that that wasn't close. What about 2.333? What if we square that? I get 5.44. That's a lot closer, isn't it? Well, Newton wasn't satisfied with that guess. He wanted to get closer, so what do you think he did? He did it again. And I'm going to show you guys a really short way of doing this in a second here, but you need to understand the concept because we're going to apply this in other areas coming up here. Now, once I come up with that spot, what do? Find the tangent line. Well, look at that. I mean, that's all of a sudden we come up with an extraordinary guess, don't we? Let's figure out what that is, okay? So we need a point on the line, and we need the slope. So 2.3 repeating is the x value for the point on the line. How do I come up with the y value? Plug it in. So if I take 2.33 and I square it, and I subtract 5, I get 0.4 repeating. How do I find the slope? Without the calculator, right? Okay, so good point. 2.3 repeating is the same thing as 7/3. So we're using the calculator right now as cheating, but you can just square 7/3, you get 49 over 9, right? And then subtract 5. So you could write all of these as rational numbers pretty easily. Okay. So just for the sake of time, we're not gonna do that. We're gonna use our calculator as help, but just put yourself in mind of it if you didn't have a calculator. Slope, the derivative is 2x, right? So how do I find the slope at that x value? Yeah, I just take 2 times that. So I get 4.6 repeating. Is that enough information to now write an equation for the line? Yeah. And I do the y minus y1 is equal to m times x minus x1. And so the y value is 0, so I end up with a negative 0.4 repeating equals 4.6 repeating times x minus 2.3 repeating. I'm going to divide both sides by 4.6 repeating to get negative 0.4 repeating over 4.6 repeating equals x minus 2.3 repeating. Now what? Yeah, so 2.3 repeating minus 0.4 repeating over 4.6 repeating. That's going to be my new guess, isn't it? We're almost done where I can show you some of these really cool connections here, but please look at this. Where did 2.3 repeating come from? That was our new guess. Where did the 0.4 repeating come from? That was f of that, right? Where did the 4.6 come from? That's f prime of that, right? So you can see the formula develop. Let's see what that value actually is. I got 2.3 repeating minus 0.4 repeating divided by 4.6 repeating. And you can see you get 2.238,095. Now, again, Newton could write these in a rational form or as a fraction instead of a decimal like that. But let's see how close he is now. 2.238,095. If he squares that, what does he want to come up with? Yeah, I mean, if he did it once more, we would agree that it would be ridiculously close, right? So what we're going to do is we're going to try to come up with a formula so we can make this quicker. And you guys need to be able to look back and forth, left to right, to help me out here. The function, we come up with f of x. In this case, we came up with x squared minus 5. And for our initial guess, we're going to call that x sub 0. Those are two things that we started with. Who can then tell me what our point on our line is? X sub 0 is the x value. F of x sub 0 is the y value. How do we find the slope? So that'll be f prime evaluated at x sub 0. We've got those points in place, right? So now it becomes y minus y1 is equal to m times x minus x1. What is the y value? It's 0. So I have negative what? F of x sub 0 equals f prime of x sub 0 times excellent. Now, yeah, hopefully you understand, you guys, why I took you through this first as opposed to just giving you this. Okay, I want you to help make the connection there. Now, we're trying to solve for x, right? Since that's my new guess, I'm going to call that x sub 1 because it's my next guess. So it's after the x sub 0. In order to solve for that, I'm going to divide by f prime. And I'll get negative f of x sub 0 divided by f prime of x sub 0 is equal to x sub 1 minus x sub 0. Add the x sub 0 minus f of x sub 0 divided by f prime of x sub 0. That's equal to x sub 1, our new guess. Do you see the connection? I asked you guys where these pieces come from. You said, well, that's your guess. That's the function evaluated at your guess. And that's the derivative evaluated at your guess, right? Now, that's one way to write Newton's method as a formula. Here's another way that people write it. They say, if you want to know the next guess, you take the previous guess, the first guess, minus f of x sub n divided by f prime of x sub n. You know, there's a number of different ways to write Newton's method as a formula, but you know, that's kind of a little bit of the insight, okay? And that's what we're going to use the rest of today and then tomorrow. Now, everybody needs their calculator out. This is where it gets really cool, okay? Nope, don't need that, okay? All right. Now, we're going to focus on the square root of 7, okay? You don't have to write this down anywhere. You could just follow along. We're just going to have fun right now. If you want to write it down, you can. We're just going to explore a little bit. I got the square root of 7, and you hit enter on your calculator, and you get 2.64575131. Ever wonder how your calculator comes up with that? Like, I get that the calculator knows how to do 8 divided by 3, and it could come up, you know, it could do the algorithm that we do. We don't really have a method for coming up for that. I mean, how in the heck does your calculator even come up with that? And you might say, and you guys might be quick to say, well, I know how the calculator comes up with that. It just it memorizes all those values. They just input them. So you really think that that somebody sits down and punches in the square root for that guy too? You know, I mean, it can do any of them. It doesn't matter what you type in. There's an infinite number of numbers that your calculator can find the square root of, right? Yeah, there is. It's pretty ridiculous. So, how about this? X squared minus 7. You understand why I'm using that, right? If I zoom 6, where does that cross the x-axis? Between 2 and 3. And if we wanted to find that spot, you would do second calculate what? 0, number 2, right? You know that the square root of 7 is between what two numbers? 2 and 3. What are you doing? A left bound? I'm saying this could be between certain two values. It could be between 2 and 3. 3.1, who cares? We know what two values is between. What's your calculator ask you to do that? Do you see the connection to Newton's method? Your calculator is doing Newton's method, folks. Since you didn't make a guess, you just press enter. It just starts guessing at 3.1, and it does Newton's method to come up with that. Okay, one more shot to show you the connection. This is cool. What's the function that has a solution to the square root of 7? X squared minus 7, right? So all good with that? So what's f prime of x? 2x. So Newton's method would be, if we want the next guess, okay? If we want the next guess, we would take x minus the function divided by the derivative. I mean, that's the rule, right? I'm going to type that in. I go x minus parentheses x squared minus 7 divided by 2x. Now I'm going to go to my table here. Okay. What do you want to be your first guess? Oh, come on. Make a bad guess. 3. We all go 8? We'll do it. We'll do it. We'll do 8. All right, make it a bad guess at 8. What is that? That's my new guess. So I just type in 4.4375. What's that? It's my new guess. 3.0075. What's that? That's my new guess, right? 2.6675. That's my new guess, right? 2.6458. And you might be like, oh, well, I get the same thing over again. If you can see that that's 2.6458. As you scroll over, you can see it's 2.645753 Is that what I have? And if you take that value, 2.645, and we'll just go to 8, and we'll square that. You can see you come up with a value very close to 7. You see how Newton's method works pretty quickly. If you see how it's built into your calculator, folks. Last year, when I told you guys to do second calculate 0, number 2, did you remember that you were kind of wondering? Well, yeah. Do you wonder why I was giving you left bound and right bound and stuff like that? Does it make sense now? It's going to make even more sense when we do some work on Thursday or if we have snow day tomorrow on Friday. No assignment today, but you guys got to keep Newton's method in the back of your head. We're going to pick up with it next time. We good? If Cal asks what we did in calculus, what should you not say? Don't say nothing. We didn't do anything. Did we do something today? Yeah, we investigated Newton's method. Oh, I'll look at it. I didn't do it over lunch. I ate instead. No.